Hey there, CJ Math students. Welcome to classwork, homework 8.9, mean absolute deviation. Make sure you write your video score here, and make sure you watch any other videos you have not completed to get your score. This is Due Monday. Calculators are okay. We're jumping right into it. If you missed today's notes in class, here they are. The main idea is that when we have data, we have variability in it. It means it's a way to describe how far the data is away from the mean or the median. So those measures of center, like, okay, not every dot falls right in the center when we're talking about data. Sometimes they're above the center, sometimes they're below the center. And today what we're trying to figure out is how far away from the center are they, right? So to find mean absolute deviation, first you find the mean of the data set. So you take everything up, you divide it, add it up, and divide by how many you have. So in this family, we have a number of family members for each family, 3, 2, 4, 2, 5, 6, 2. So the average, added up, 24 divided by 7 is 3.4, right? Next, you're going to find the difference of each piece of data from the mean. So basically, the deviation from the mean. Deviation is a good word for difference, right? So 3 minus the mean, right? 3.4. 3 was the number of families minus the mean, 3.4. You are negative 0.4 away from the mean. 2 number, a family with 2 members. 2 minus 3.4. You are negative 1.4 away from the mean. A family with 4 members. 4 minus 3.4. You are 0.6 spaces away from the mean. Again, a family of 2, and so on. 5, 6, 2. Once you find the difference, notice how the mean doesn't change. Once you find that, you just plug in that right in there. You're going to take all your values, whether they're positive or negative, and you're going to take the absolute value. So remember, absolute value is how far a number is from 0. So any negative number is always positive. Any positive number is also positive. So negative 0.4 is 0.4. Negative 1.4 is 1.4. The absolute value of 0.6 is 0.6. The absolute value of negative 1.4 is 1.4, and so on and so forth. And finally, after you've done all that, that's all the hard work, all you're going to do is find the average of the absolute deviation. So here are all your absolute deviations. You add them up, and then you divide by how many you had. So when I added this up, I got 9.4, and then I divide by 7 because there were 7 of them. And my absolute deviation is 1.3. So basically what 1.3 says is, on average, data is 1.3 spaces away, units away from the mean. So in this case, the average family, while they have 3.4 members, it is on average that the next family is 1.3 above or below that mean. The next thing we reviewed today was the IQR, or interquartile range, and this is the middle of half of the data and is centered around the median, right? So if I wanted to find the interquartile range of the average high temperature in Seattle, Washington, first thing I want to do is take all the data points and order them from least to greatest, right? Why? Because in step 2, I want to find the median. So of all these temperatures, I had 2 numbers left in the center, 58 and 60. I added them together, divided by 2, so my median is 59. Now that I found the median, basically I want to take the first half of the data, find the median of that, and then take the second half of the data and find the median of that. So the median in the first half of the data, if I cross out 46, 46, 53, 58, is 50 and 51. So add them together, divide by 2, you get 50.5. The median in the second half of the data, if I add it all together, cross off 60 and 64, 75 and 76, I have 70 and 7. I didn't really need to do 70 plus 70 divided by 2, but quarter 3 is 70. IQR is simply subtract now to find it. So 70 minus 50.5, quarter 3 minus quarter 1, equations right there if you forget, gives me 19.5. So my interquartile range, or all the data that is centered around the median, is 19.5. So finally, we did some problems together. Here's an example of a bag of M&Ms, and we found the absolute mean deviation. The mean amount of green M&Ms in a bag is 6.8, and then we found that some bags can have about 3.04 either more green M&Ms or less green M&Ms than our mean usually. And then we did the amount of cars running red lights, right? And we found the median in IQR. What I want you to do is find the number of televisions in a household. Find me the median and the IQR. First thing you want to do, order the data. So a frequency table, each tick means we have a data point there. So 2 zeros, 4 ones, 8 twos, 3 threes, 2 threes, 3 fours, and 1 8. All right, so find the median and the IQR of this. So our median is 2. I ended up having two 2's in the center, so 2 plus 2 divided by 2, simply 2. All right, now I'm going to go ahead and find my quarter 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So let's cross off 4, 1, 2, 3, 4, 1, 2, 3, 4, and there it is. Quarter 1, Q1 is equal to 1. Same thing here. 1, 2, 3, 4, 1, 2, 3, 4. Actually, sorry, I made a mistake. It should have been 1 and 1, which still gives me 1. And here, 1, 2, 3, 4, 1, 2, 3, 4, 3 and 3, which should give me 3, right? So your quarter 3 is equal to 3. So your IQR is just simply 3 minus 1, which is equal to 2. All right, on your homework, basically what's going to happen is in problems 4 through 6, you're going to work with mean absolute deviation, and then in problems 7 through 12, 12 at the bottom there, you're going to go ahead and work with interquartile range. Best of luck. Call me if you have a question.